Here at ECOC TV, we're always happy to be joined by Michael Lebby, who's the CEO of Lightwave Logic. Michael, thanks for coming over and chatting to us. This time last year in France, you just hot-footed it over from ringing the opening bell at the NASDAQ, which was a great highlight. I know you were excited about that. What's happened in the last 12 months for Lightwave Logic?
It's been an absolutely great year for us. And I gave a talk here on Monday morning, and the focus of the talk was on foundries, silicon foundries. So one of the big things we've done since going to the NASDAQ, and the NASDAQ is now, you're on the big boards, we have the resources to do what we need to do. So we're working with foundries, and the big thing for us is to be able to prepare for scale and volume of our electro-optic polymer technology, which is the super fast modulator technology. And over the last year, we've done a lot of progress towards that. And this is going to turn into a really fabulous conference for us. And in fact, tomorrow we have 2 post-deadline papers that show world record results for the performance of polymers. And so this is really, really exciting. So yeah, it's been, I know you mentioned hot-footed, I remember that term last year. But yeah, it's been a great year.
Fab, very glad to hear it. You mentioned speed and volume then, and that just struck me because as we've been hearing around the conference, those are 2 really big issues that are being discussed. Have you picked up any particular themes while you've been going around the place?
Yeah, actually I have. I mean, high speed, ultra high speed is really important, but also ultra low power and small size. And a lot of the folks here at the conference are talking about, what's happening next. And we're seeing prototypes at this conference of 800G transceivers using different types of modulator technologies. And some of these folks are saying, well, how do we architect to go to 1.6 terabit per second? And even a few of them are saying, well, actually, what do we do to get to 3.2 terabits per second? And how do we manage the electronics? How do we manage the optics? Well, we at Lightwave Logic are sitting with a technology with much faster optics. So we have a platform that really addresses that. But you also have to work with the electronics too. But there's other technologies as well. So we're not the only fast modulator technology. And in some of the things I've seen at this conference really exciting. There's been a big discussion on direct detect versus coherent. And one of the interesting arguments is direct detect, especially 10-kilometer optical links, interconnects, is very low cost, whereas coherent is very high cost, and you can only get the cost down if you have volume. Direct detect, you don't need the volume, so you've got that argument going on. And that seems to be quite popular in a lot of the debates. And so we're seeing those types of issues as well as how do you get faster optics through different modulator designs. So I think in general, it's been a really good conference from that standpoint.
No, I agree. It's been a really interesting debate about different people thinking about different times and slightly different ways of getting forward with that. But I know you have a particular interest in hybrid PICs, so maybe you can tell us a little bit about how you think the roadmap works there.
Yeah, so let me unpack that a little bit. A hybrid PIC, a PIC stands for a photonic integrated circuit. And a hybrid PIC means it's not a pure photonic integrated circuit. So if you look at the incumbent technologies there, you've got pure indium phosphide as a PIC, and you've got pure silicon photonics as a PIC. But what people are now realizing is that you're going to have to mix and match modulator technologies in order to optimize the performance. And so a hybrid PIC means you're going to have to hybridize with another material. Now we're using electro-optic polymers, so a hybrid is polymers plus silicon photonics. It could well be thin film lithium niobate, it could be barium titanate, it could be plasmonics. So there's a number of different technologies that are all looking quite attractive. And one of the things I'm presenting on this afternoon is the ECOC rump session, which is not televised, it's not recorded, but it's an open debate on the roadmap of what makes sense for a lot of these systems going forward. And I'm presenting the Datacom PIC, hybrid PIC roadmap with a number of different technologies. And we're going to have an open debate to see which technologies make a lot of sense. But in general, the industry is looking at a mix and match of different technologies in order to achieve these 1.6 terabit, 3.2 terabit, 6.4 terabit per second type solutions for modules and interconnects as we go forward in the next decade is actually incredibly exciting.
Sounds it. I mean, do you expect that there's an open door that you're pushing on with that, or are people sort of pretty much stuck to one particular technology?
I think what's happening right now, people have chosen their technologies, and you have seen indium phosphide picks, and you've seen silicon photonics picks, and they're incumbent technology. They're out there in the traffic, but people are now realizing that's not going to get them to where they need to go. So they've got to do something different. And if you want faster optics, single lane faster optics, which is what everybody's looking at, then you're going to have to try and choose another technology. So the net is, for companies like ourselves, this is super exciting. And so with our results that we're presenting in the post-deadline sessions, the world record results, for us this is going to be great.
Fantastic. Well, as always, Michael, it's a pleasure to talk to you. I know you're a busy man, so we'll let you get back to it. But thank you for coming and talking to us at ECOC TV.
Thank you, James. Really appreciate it.